Hi, today a few members of our electrical team will be talking about the control system that we use on our robots. We will briefly go over these components as well as their functions and applications on our robots. First off, I wanted to give a quick overview of the entire system. So this diagram includes many of the components that we will be discussing in detail later on in this video. Once we start introducing each individual component, it may become confusing as to how they connect with other components, so I hope that this diagram can help with understanding how each component fits into the bigger picture of the entire robot. So first off, the picture on the left depicts a battery. So the battery is the voltage source of a robot, which provides power to all the other components in the circuit. Something else to remember is that the battery connects to the circuit breaker, which in turn connects to the PDP. But don't worry if you have no idea what these components are, because we'll be talking about them later on in this video. In the picture to the right, the circuit breaker has a power wire that runs upwards to connect to the battery. To check the voltage of our batteries, we use a tool called a battery beak. So a multimeter is another tool that we can use to check the voltage of our batteries. However, it can also measure electric current and resistance in addition to voltage, as we mentioned with our battery beak. So we will be using the waterfall analogy to help make sense of current, voltage, and resistance. So current is the rate at which electricity flows, and this is analogous to the rate of water flow in the waterfall. Voltage is the pressure that causes current, so it's like the height of the waterfall, which causes the water, or current in our case, to flow in the first place. And lastly, resistance is the opposition to current flow. So you can think of this resistance as the obstacles that slow down the water flow of the waterfall. Additionally, these three quantities are related by Ohm's law, which says that voltage is equal to current multiplied by the resistance. Next, I'll be touching on the circuit breaker, which essentially acts as the emergency power switch of the robot. So as mentioned before, it connects the battery to the PDP. And when you press the red button on the circuit breaker, it will actually break the connection between the battery and the PDP. And since the PDP connects to many other components, this will prevent all other components from getting power. So in this way, the circuit breaker can help protect all other components as well as the wiring on our robot. So specifically, we use a 120 amp circuit breaker, which basically means that current flow is cut off when the current exceeds 120 amperes. However, most often, the circuit breaker will be used to turn the robot on and off.
The next component we'll be talking about is a PDP, or power distribution panel. As its name suggests, the function of the PDP is to distribute power throughout the robot. The PDP connects to the battery via the circuit breaker through its main battery input. Next to the main battery input is our CAN ports. On the left-hand side of the diagram, you can see smaller ports that link power towards the PCM, the VRM, and Roborio, which are all components we'll go over later in the video. Throughout the longer side of the PDP are 30 and 40 amp channels that are typically connected to motor controllers. These channels are labeled from 0 to 15. Next, we'll be talking about the Roborio. The Roborio functions as the brain of the robot. The Roborio controls the rest of the electrical components in the robot. It runs Linux OS and supports languages such as Java and C++. And although not technically supported, many teams still use Python. Along the sides of the Roborio are pins to connect to supplemental sensors. Additionally, the Roborio also supports a Navix or gyroscope to be attached, which allows the robot to operate during autonomous period.
Next, we have the VRM. So basically, the voltage regulation module gives power to smaller components that help the robot run. It receives power from the PDP, specifically the 20 amp input. The VRM has 4 different voltage and current output options that range from 12 volt and 5 volt base. It gives power to smaller components, as I said, such as the radio, which uses 12 volt 2 amp input. It gives power to various sensors that usually take in 5 volts. And then also, as of last year, it gave power to our network switch, which was a 12 volt 2 amp, which was used as an extended D-Link, which means that it powered multiple devices using Ethernet. The VRM has an LED indicator for the 12 volt and 5 volt. On indicates that current is going through desired input and nothing is wrong. Off means that no current is going through or the internal breaker has tripped. Motor controllers are a very important part of the robot. It provides power to all the motors that control our manipulators and that help drive our drive base. So basically what our motor controller does, it turns electrical input into mechanical power. based on current draw, it determines the speed of the motor. The motor controllers get their power from the outer ports of the PDP. There are several different types of motor controllers available to us, but as of recent, we mostly will use these. A Victor SPX, which is used for smaller components, smaller motors, like SIMs. Talon SRX is what we mainly use. We use these motors to control the manipulators on the robot. There is a SparkMax, which is exclusively for the Neo 550. We used it in 2019 for the drivetrain, and it can also be used for shooters because of high RPM. And then last, there's a Falcon 500, which we used this year for the drivetrain robot. Falcon 500 is probably one of the strongest ones we've had right now because it's the most recent motor controller that came out. I'm not going to go into much detail, but this is the basic information you need to know about motor controllers and what they do for the robot.
Next, we have the PCM, or Pneumatics Control Module. The PCM essentially controls the robot's pneumatic system and airflow by regulating the current that enters the solenoids. Pneumatics can be defined as the manipulation of airflow to push and pull pistons. In addition to the solenoids, the PCM provides power to the compressor and pressure switch and receives current from the PDP. It connects to the motor controllers via the CAN chain. The radio, or router, allows the computer to wirelessly connect to the robot, which makes it possible to deploy and run code. It is powered by the VRM and connects to the Roborio and VRM via a PoE cable. It contains several lights at the front that indicate different statuses of the router. Finally, the RSL, or robot signal light, is a light that is mounted on the robot and used to signify the robot's status. If it is on and blinking, the robot is on and enabled. If it is on without blinking, the robot is on and disabled, and if it is off, either the robot is off or the Roborio or RSL is not wired properly and not powered. Thank you for watching our video on electrical components.